we have two types of rules in here to analyze based on shape of distribution, right? So here it is. If our distribution is mentioned to be a normal distribution, meaning a bell-shaped, symmetric distribution, again, in a measure of central tendency, the mean is the most, measure of central tendency that will explain, the centrality of this distribution. So with this being said, for population mean, that is our mu, and sigma in here is our population standard deviation. Again, we said the last time that if you are considering one standard deviation above the mean and below the mean, then that interval in there will comprise 68% of the data set. Okay? Two standard deviations above the mean and below the mean, so that area over there will account to 95% of your data set, and three standard deviations above and below the population mean will comprise 99.7% of the entire data set. Again, this only works if your data set is confirmed or mentioned to be normally distributed, all right, or bell-shaped. Now, let's read this question in here about what we call the IQ test, or what we call Stanford-Binet IQ test, which is usually used by psychologists, educators, psychometricians to measure IQ, right? Or what we call intellectual quotient. Anyway, so let's read this one in here. Tiff, go ahead please. Number 31. The Stanford-Binet.
Oh, the Stanford-Binet.
Yep. Okay.
Binet intelligence quotient measures intelligence. IQ scores have a bell-shaped distribution with a mean of 100 and a standard deviation of 15.
Thank you. All right. So as you may notice in here, two values were already given, right? Mu, or the mean, population mean, is given to be 100. Okay. And sigma, the population standard deviation, is already measuring 50. Okay. So how do we consider now answering these questions? Let's read letter A. Okay. Andrew, go ahead please. What percentage
of people has an IQ score between 70 and 130?
Thank you, right? So 70 and 130, right? So if we can try to see that one on this data set in here, all right? Let's apply this data set for such, right? So our mu is already what? 100, right? So let me put in here our mu to be how much? 100. Okay. Okay. Now since our standard deviation is 15, then that means you add 15 each. Okay. On the right side. So what's 100 plus 15?
115.
115 IQ. What about this one?
130.
130 IQ, right? And in here, 145. 145.
145, yes sir.
Thank you. I get it, right? So as you may notice in here, you are one standard deviation, that's 15. Two standard deviations, that's 30. And three standard deviations, that's 45, right? Above the mean, right?
Okay.
On the other end, we're gonna do what? Subtract instead, okay? So you can use your calculator for such. 100 minus 15.
85.
85. All right. Okay, continuing. Minus another 15.
70.
70. Very good. All right. And the last one, minus another 15.
55.
55. Okay. So there we
Yes,
go.
sir.
That's our data set. Okay. Now in this case, it says we are considering the percentage of people with IQ scores between 70 and 130. So if we want to shade it in here, where is that? This is 70 and this is 130, right? So with that being said, we are trying to figure out what is this area, right? What part of the graph is this area in there? Good. So as we may notice in here, it says already in here, well, 130 is two standard deviations above the mean, and 70 is two standard deviations below the mean, right? So we are assuming it to be how much?
95.
But 95%. Thank you for based from our empirical rule, right? Well, anyway, let's confirm if that is correct based on our calculator, right? So we're gonna use a calculator for such, and here it is. We're gonna go to our Desmos and plug it in here, right? So we're gonna put the following: normal dist, because we are assuming the distribution to be normal, right? Or bell-shaped. Parenthesis, it's always gonna ask for mu and sigma, right? So what's the mu? 100, right? And what's sigma? 50. Again, it's already given anyways, right? Now to clearly see the graph, I'm gonna click on the graph settings on the upper right hand corner, right? Sorry for this, let me just X this out so that you can see it clearly. You see the graph settings, and you see this X and Y axis. As you may notice in here, we are talking about what? 3 standard deviations below and 3 standard deviations above the mean. So we can put in here the following, right? On the X minimum, what's the mean again? 100 minus 3 standard deviations below. That's the minimum, right?
Okay.
Or you can just plug in 55, right? Okay. On the max, what you're gonna put in here? The mean again, 100 plus 3 standard deviations above the mean. So that's 50, right? Okay. Or you can plug in 145, right? Just to be specific with that. Now, typically for the steps, we usually put in the standard deviation. In here, what's the standard deviation? 15. All right? Okay, so again, on the steps, I put in the standard deviation mentioned, 15. Get it? Okay. Now, the y-axis is the probability, right? And or relative frequency, that's always less than 1, right? So typically, or ideally, it's 0 to 1. But you can adjust it depending on how high you want it to be. Since this is like too flat, so what you're gonna do with that one? Make it a little bit lower, right? Let's say 0.5. It's still a little bit lower, right? So make it lesser, right? Just to clearly see how it looks like. Let's say 0.04. Ooh, okay. That's a good, shape that we are looking to. Are we good, guys? Okay. Now, let's verify. Can we verify that 70 to 130 will give us 95% of the data set? So let's see. I'm gonna click on CDF, or the cumulative distribution factor. On the minimum and maximum, I'm gonna put what? Those two values, the 70 and the 130, all right? So let's put in here the following: 70 on the minimum and on the maximum 130, right? And what have we seen in here?
95.4.
Thank you. Multiply it by 100%, right? So again, since that is the proportion or the ratio of the population, so you typically what? Copy that one and multiply it by 100%. Okay, so Control V, Control V, and then times, we want percentage, right? 100%, right? So does that verify our assumption a while ago by empirical rule that from 70 to 130 is basically 95% of our data set? Yes, right? Okay. Are we good, guys? Right, with what we did? Right?
So could we find this 95% without making the graph, just using the cumulative
yes, we
probability?
can, right? Okay, again, even without doing the graph, you can figure it out because honestly, you just did this one in here, right?
Okay.
But I would want you to consider seeing it from the graph as well because you want to visualize like, okay, how does a 95% data set look like? Okay, but again, even without the graph, it's fine, right? Not unless it's asked on the instruction like for you to graph it. Okay, but other than that, no need to actually have this one. But again, it'll be a good thing to have this one to give you a confidence of like, am I getting the answers right? Because other than that, there's no way of finding out if you are confident enough with your answer. Okay? Because as you may notice in here, does that look like it's 95% of the entire data set? Well, we can assume that this is what? If that is 95%, that this is what? 2.5%, and that's another 2.5%, right? Assuming that it is what? Bell-shaped and symmetric. Are we good? Right. So again, if you want just a computation, this will be fine. But if you want to be convinced and have more confidence with your answer, you want to visualize. Get it? Okay. Now, going back. Let's answer the next question for such. Letter B, right? Let's try to answer letter B for such. JC, let's go ahead and read that one in there.
What percentage of people has an IQ score less than 70 or greater than 130?
Okay, less than 70 or greater than 130, right? So how do we do that one, right? So, as we may notice in here, there are two things for that. So here it is, right? First one, it says what? Less than 70, right? So if it's less than 70, then I would put in here the following. 70, and this will be what? I'm just gonna leave it, okay, blank. Simply because if I leave it blank, what will happen in here? What do you notice with less than 70? If you leave it blank, it's gonna turn out to be what? 3.
Infinity? Oh, sorry.
Negative infinity, right? So in short, it goes infinitely to the left. Get it? So it gets all the values, values. Good. Or, you know, I mean, it would make sense that since this is IQ score, what is the lowest score? A 0, right? So if you wanna be specific with that, right? So you can just plug in 0. As you may notice, even if you plug in 0.0227, even if you don't plug it in, it's basically almost the same, right? There's just gonna be a little bit, you know, minute error, right? But other than that, any of those will be fine. Are we good, guys? Right? So that's less than 70, right? Or it also says what? Guys, what did it say in there?
Or greater than
More than 130, right? So this is what I'm gonna do. Since there are two inequalities involved for that, this is what I'm gonna do. I'm gonna recopy this one, normal dist once again. Oops, normal dist, normal. Oops, dist. The same, 100, 15, right? But in here, I'm gonna put what? More than 130. So that means when you say more than 130, that means 130 is the minimum. And the maximum, you can leave it blank, all right? Like such, right? Again, once you leave it blank, it's gonna be what? Infinity. Get it? So that means it's gonna get all the values towards the right in there, no matter how big your IQ score is, right? But definitely, there's you know, the ceiling score for IQ, right, cannot be like more than 1,000 or anything, right? But again, theoretically, if you leave it blank, it's gonna be infinity, right? Are we good? Now in this case, what you're gonna do with those two?
Add them?
Add them together, right? But also, as you may notice, what do you notice about those two numbers?
They're the same.
They are the same, right? Why? Well, this is what? 2 standard deviations, right? This is also 2 standard deviations, but away from each other, right? So if you add them all together, what's that gonna be, guys? So here's what I'm gonna do. I'm just gonna copy this, put in here. Oops, Control V. Now since they're the same, I'm just gonna double it, right? Good. And then multiply it by 100%. Good. Right? And how much did we get? 4.55%. Okay, are we good, guys? So that'll be our answer for such letter B, right? What percentage of people has an IQ score less than 70 or greater than 130, right? Now, as you may notice in here, this says 5%, right? So why is it 5%? Well, it looks like in this case, it wants us to have what?
1 digit rounded.
The integer, right? The integer values. But if you go back in here, 4.55%, well, that's 0.5, right? So again, 5 and up, you can round up. Are we good, guys? Get it? Got it, guys? Right. So in that case, so since 0.5, that means you round 4 up, which basically will be 5%. Are we good, guys? Right. Any questions with that? Questions with our what we call empirical rule. Okay, now let's go to our what we call this Chebyshev inequality. Okay, so
Is that like a name? Is that a mathematician?
Mathematician, right? Basically mathematician and statistician as well, right? Let's read this Chebyshev inequality. You can read it on your end as well, right? So it says in here the following, okay? First of all, it should work on any shape or any type of distribution. Skewed to the left, skewed to the right, normal distribution, uniform distribution, any type of distribution, it should work. Get it? Okay. Unlike empirical rule, it can only work on normal distribution. This one should work on any type of distribution. Okay. Now, what do we need in here are the following, just the same as empirical rule: population mean and population standard deviation. Okay. Now, here it is. It only tells us the following, right? That if you want to know, right, the percentage, right, of the population that is, right, or that has scores K standard deviations above the mean and also K standard deviations below the mean, then that percentage of people will be equal to what? 1 minus 1 over K squared of the data set will always be there. Again, that K is how many standard deviations you are away from the mean, right? To the right and to the left as well. Okay, now let's see how this is gonna work. Let's read this number 37 and how we can use Chebyshev inequality for such, right? Kalina, let's go ahead and read number 37. Thank you.
In December 2018, the average price of regular and oil gas excluding taxes in the United States was $3.06 per gallon. According to the Energy Information Administration, assume that the standard deviation price per gallon is 6 cents per gallon to answer the following.
Thank you. All right. So it already gave us the average or the mean. What's this? Price of unleaded gas, $3.06 per gallon. Right. Now the standard deviation, it varies by how much? 0.06 standard deviation. Right. So that means 6 penny. Get it? Okay. Now, how do we analyze this one? Let's read letter A. Okay. Jordy, let's read letter A. What minimum?
What minimum percentage of gasoline stations have prices within 3 standard deviations of the mean?
Thank you. Right. Once again, particularly take note of this. It doesn't mention that this is normally distributed, right? So who knows? It can be skewed left or right. It can be uniform distribution. It didn't say that this is normal distribution, right? Now, let's analyze that one in here. So in this case, for Chebyshev inequality, what is the mean again? Mu? What's the mean? Mean in there, guys?
$3.06.
Thank you, right? Mean, average, they're basically synonymous, right? So when you say the mean or the average, they're the same. Okay, got it? Okay. Next one. What's the standard deviation?
6 cents.
0.06 or 6 penny, right? 6 cents as well, right? So that means you see this sigma, right? So your sigma in here is 0.06 and your mu is what again? 3.06. Okay. So that means your K in here, it says what? How many standard deviations above and below the mean are we talking about for letter A?
3.
3 standard deviations above and below. So that means your K is 3. Get it? So again, your K in here is the what? Number, right, of standard deviations, right, away from the mean. So it says in here 3, right? So in that being said, then we can say that this is 3.06. What is this in here then? 3.06 plus 3.06 cents. Good, right? Now in here, what is this then? This is 3.06, right? Minus 6 penny. Get it? Okay. Now the question is, what's the question? What is the minimum percentage of gasoline station that had prices within 3 standard deviations of the mean? That means above and below the mean. What is the percentage of that population? You see, so you see that K? Just make it what? 3 standard deviation, right? So for letter A, what's the answer? One minus 1 over, what's your K again? It says 3 standard deviations above and below the mean, right? So 3 squared times 100%, right? So what's that gonna be, guys, on your calculator? Right? Let's plug it in our calculator and see what percentage will that be, okay? So according to Chebyshev's inequality, we have the following: 1 minus 1 over 3 squared, right? Times 100%, right? So in short, what percentage of the gasoline prices is within that interval? Okay. So what percentage of gas prices are within that interval?
88.9.
88.9%, right? Are we good, guys? Right? So with that being said, for letter A, then these values in here will account to what? 88.9% of all the gas prices. Get it?
Would you round up on it?
Well, it depends on the question, right? But that's a good question there, Tiffany, right? Typically, for statistics question, definitely it will tell you if it needs to be rounded off to the nearest tenths, hundredths, right? Or integers. Did it say in here? It didn't say anything about minimum percentage of how it should be rounded off, but it looks like in here, it was rounded off to 1 decimal place. We good? But typically, for gas prices, you round it off to what? Nearest cent or nearest penny. Are we good? Because money, it has cents until the what? 2nd decimal place. Are we good, guys? Okay. Now let's read in here. Letter B. So that confirms our 88.9%, right? Let's read letter B for such, okay? Sydney, let's read letter B. What minimum percentage?
What minimum percentage of gasoline stations had
Prices?
prices within 2.5 standard deviation of mean? What are the gasoline prices that are within 2.5 deviation of the mean?
Thank you. All right. So we'll verify if that answer is correct, right? But again, we're talking about what? How much? Thank you for that, Sydney. 2.5, 2.5 standard deviations above the mean and below the mean, right? So what percentage that will be, right? Let's go back in here. So 2.5 standard deviations, right? So this is 3 a while ago, right? So what we're gonna do is change your K now in here for from K equals 3 to 1. What's your K in this case?
2.5.
2.5, right? So as simple as that, okay? So for B, let your K be equal to what? So let's call this K1, in K2, 2.5. Yep. Okay. So you see those 3's in there? Just change them to 2.5s. Okay. So change this to what? 2.5 instead, and 2.5 instead. Okay. Are we good, guys? Right. So what are those values? How much are those? Right. So let's put in here the following. The first one, 3.06 plus 2.5 standard deviations of the 2.5 standard deviations, right? 0.06, right? So how much is the first one? $3.21, right? So that's the highest value in here. So this value in here should be what? How much it says in here? $3.21, right? So what's the lowest value at a 2.5, right? So you see the plus? I'm just gonna change it into minus, okay? So here, I'm just basically gonna copy this, put it in here, and put what in here? Minus instead. Get it? Okay. So the lowest gas price on a 2.5 standard deviation away is how much? $2.91. Okay, so you see this point in here, that is now your $2.91. Again, that's 2.5 standard deviations below. Okay. Now, what percentage of all the gas prices fall within that interval? Right? So how much of them fall within that interval, right? So how do we do that one? So basically the same formula for Chebyshev inequality, you just change the k into what? 2.5,
2.5.
right? Or 2.5. So as simple as that one, guys, right? So you see that 3 in here a while ago from letter A? I'm just gonna change it to 2.5 or 2.5. Don't forget the square. How much of the data set is in there for letter B?
84.
84%, right, of the data set. So in short, if there are 100 gasoline stations or 100 gas prices, 84 of them will fall on that interval from $2.91 to $3.21. Again, I'm just making an assumption. If there are 100 gas prices or gas stations, then 84 of them will have that interval of gas prices. Good. So that's we're gonna put in here for letter B. 1 minus 1 over 2.5. Okay, 2.5. That's your K. Away from the standard deviation, and it says in here 84%. Again, the rounding off in here depends on how the question was instructs you to round it off, right? But basically for money, 2 decimal places, round off nearest cent. For percentages, take note of the question. If it says integer, if it says hundreds, if it says tenths, then do it accordingly in terms of rounding off. Are we good, guys?